Hello again, my dear friend. So, your first request was about just foundation and the soil model going to be more Coulomb. Very good. Very simple. We created the model and everything is complete. Now, in the stage construction, we are going to active whatever we need. What I mean, look, you open the model. Very simple. Go to stage construction. Delete everything like this, every face, all the faces. Okay, initial phase does not have the calculation but soil. Initial phase, in this phase we are not going to choose the calculation type anything but k0 procedure. Nice. Okay, next phase. In this phase what we are going to active is just the foundation itself. Go to plate, active plate 1. This is just foundation, nothing else. I didn't active any plate which going to be the roof. I'm not going to active any embedded beam which going to be the piles. So if I'm going to right click on the first soil and hide it, you can see all the foundations are not activated. They are not exist in our calculation. No beam which going to be represent the beams and the columns. So just the foundation and the load of the foundation, of course. Surface load 1. No, excuse me. This is the foundation. This, okay? Very good. Let's see. Mhm. We need to do one thing. Go to a structure. Go to structures and right click on the foundation. Go to create surface load. Go back to mesh, make a mesh medium. Very simple. Very, very simple. Okay. Go to this part, select point for curves. Very good. The center of our system is going to be the center of our foundation. We need a specific point which going to be used in the output for creating the curves, the diagrams we need. But that point, if the z coordinate for that point going to be 0, is going to be in the plate area. We need to choose that point under the plate in the soil area. We are going to change the number of 0 to minus 10 centimeter under the foundation, minus zero point 0.1. Let's search closest point we can find for this coordinate. These are not our points we need. The closest point is minus 1. It's too much in deep for our system. What should we do? We close this output system. Going back to a structure, going to point, create a point, put a point wherever I want. Click here, click on the point again, give the coordinate 0, 0, minus zero point 0.1. Very good. Now keep the key, control key on your keyboard, left key on the mouse, and rotate a little. This is the point we need. Look, this point is on the pile, but remember, this pile is not going to be active in our project right now, in the first step. But we cannot use this point for curves always because we have a pile here. Double click again on it, select it. Okay, very good. Select excuse me, select the point, give it a little 10 centimeter to the X. That means 10 centimeter off from the pile. So the point going to be completely isolated, completely independent from the pile and the foundation plate, just surrounded with the soil around it. Let's go to mesh. Get another mesh. Very good. After the mesh is complete, simply go to this point, select point for curves. Very important. What was the point coordinate? Minus 0.1 for x, 0 for y, minus 0.1 for z, search closest. Note 265, the exact point we need. Select it, update it. Go to stage construction or go to flow, go to water. You remember the water condition. Go to stage construction. Delete this phase one. Very good. Initial phase was only soil. Phase one only first plate foundation, and installation of the plate. After that, phase two, surface load. Look, surface load here, just on the foundation. Let's deactivate the eye behind the beams. We cannot do that because in here we don't have any beams. I'm going to click on here. You cannot see it. Even going to activate it and do this, but it's not going to work. So just it's not working. For better understanding, you can see the plate is under the surface load for itself. So we have a simple, completely system based on one surface load for our plate. Without a space. Surface load. Foundation surface load. In this situation, just one click on it, we can rename it, but only we can use all the words after each other without a space. Foundation surface load. Plate one. Foundation. Done. Save. Okay. In surface load, we're going to use specific situation here. Change the static load, surface load, distribution load uniform into the z-aligned increment. Change the number of the z to minus 1000, and the increment part is minus 1.02. That means each time 1.02 kilonewton per square meter per meter load going to increase, one step of calculation going to recalculate it. Is this number going to increase more to reach the number of 1000? Then the calculation is going to stop. We're going to have a bearing capacity system here. So, phase one, let's rename it. Installation of foundation. Phase two, let's rename it. Activate the surface load of foundation. Done. Very good. Very good. Right now, everything is ready for a static simple situation. But if you remember, we have water condition too. In model condition, in water, in user water level 2, which we are going to change it to, to borehole level. That means saturated completely. without any embedded beam, without any structure, a static system, without dynamic load, with saturated system. Time till until here, everything is in order. Go to soil material properties, go to clay. We change the system smalls into the more column. Go to mechanical, remember this number, and the strength 25, 30. Change this just a small to more column 25,000 or 20,000. I remember 0.3. 25, 30 is the same. Groundwater is very fine, it's clay. What about sand? Remember this 45,000. Change it to more column 45,000, 0.3 is going to be there's completely like before. Medium is going to be like this standard. I'm going to change it to USDA to sand. Everything is okay. So we have system here. Look, if the whole system length, go to soil, go to borehole, the whole system is 100 meter and the clay is 10 meter. So that means 10% of our soil is clay and 90% of our system is sand. 10% clay, 90% sand. Very good. Right now we have an static system. What about consolidation calculation? One click on initial phase. Very good. Create here phase 3. In phase 3, installation of plate foundation under 10 days consolidation. Let's write this before installation of the plate foundation. We write it here into comments under 10 days under 10 days calculation, under 10 days consolidation. Very simple. So change the calculation type in consolidation, change the time interval in 10 days. After the installation of the foundation in consolidation system, we're going to have a simple system of the 10 days, small days, 5 days of consolidation. Done. We're going to create another system. Very good. We let the system experience the time of installation and the real time of creating the foundation in real world. Give it the consolidation time, maybe near to 1 month. After 1 month, after 20 days, we're going to start loading on the foundation. Phase 4, consolidation. Long term. Change the plastic to consolidation and give it 30 days. Very good. Very good. Without anything going to change. In here, we're going still active the plate of foundation. Plate 1. And let's give it foundation. Very good. Very good. After the plate of foundation, we are going to active for both of systems, plate of foundation for both system. Installation of plate foundation for 10 days of consolidation, and other consolidation with exact plate, just leave it there. And after that, we're going to have Loading with consolidation. All the consolidation in this situation are under drain condition. Phase 3, phase 4, phase 5, phase 3, phase 4, phase 5. Very good. The plastic going to consolidation, and the time of loading going to be near 100 days. Let's go. Okay. Go to surface load this time. Active the surface load for your foundation. Click on the surface load. Go to the arrange increment 1000 and minus 1.02. Very good. Another system, initial phase. Create another load, another part. Active the plate of foundation. Double click on it. Consolidation and activation. 10 days again. This phase, the system is under drain condition. Very good. Consolidation, 10 days, time interval. Click OK. Phase 7. Long-term consolidation on drain condition. Time interval 30 days. Click OK. Phase 8. Surface load again. Uniform set arrange increment 1000 minus 0.2. Okay. Loading with consolidation. These phases are under drain condition. Phase 6, phase 7, phase 8. Plastic consolidation. 100 days. Click OK. Click on here. Everything is in order now. The loading system in 2 different conditions. We're going to check the water condition. In every situation should be borehole. Initial phase borehole. This is going to be borehole 2. Borehole. Change everything borehole. Borehole. Be sure everything is borehole in this step 1. Borrow. Very good, very good. Click on here, saving it. Very good, very good. In specific this model, we're going to have just foundation without any structure above, without any structure under, just the load of foundation and foundation itself and the water completely saturated, you can see, and the system is going to be under static and days of consolidation. Let's see what's happening here. Remember, the first three phases are without consolidation. This phase and this phase and this phase. But these three phases, consolidation during condition, these three phases, consolidation under condition. So, what should I do now? Look, for these three, we need to create exact system. Let's go to Clay, copy Clay, okay, new, paste. Excuse me, continue. It's a small errors you're going to find out in your system. Just simply restart the system. Okay, with the restart of system, everything is okay. We have two clays. Clay, Andre. Andre no A type, first start, different kind of color for clay. What about sand? Copy, material. Okay, new, paste. Another sand. Sand, Andre. Change the system Andre in A. Another type. Yellow, whatever it is. Okay, so initial phase, everything is okay, 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 okay. Very good. But these three need to be changed. In this tree, we're going to have different system. We're going to click on the consolidation phase 6. Open the soil, undrain clay here, undrain sand here. 7. Undrain sand down, undrain clay top. Here, undrain sand down, undrain clay type top. Very good. So deactivate them first. We don't want to have them right now. Just deactivate them first. Click on save. After the calculation got finished, the initial phase also needed to be in undering system. But we have two different phases of calculation. Let's first calculate initial phase for these parts. After that, we're going to change the initial phase and active these parts. Let's go, excuse me, let's go calculating. So after the calculation got finished, we're going to continue. But we need to consider what point. Look, for consolidation calculations, all these phases, the solver type should be choose this one, multi-core direct. It's very important. It's not going to be calculated based on multi-core iterative. Just multi-core direct could calculate consolidation like this. So in here, we are going to make a save. Let's go create a save as with undrain condition. Done. Make a save as on it. Very good. Change the initial phase to calculation again. Go here, undrain clay, undrain sand. Here. Active these phases. Everything is ready to calculate again. Go to calculate. But before that, change the system to multi-core direct. multi-core direct, multi-core direct here, and continue to calculate. Very good.